Hey y'all. Today we're going to take a look at the third method for solving quadratic equations. Really quick recap. We know how to solve a quadratic equation by graphing. So you make sure it's set equal to 0 and you look for where it crosses the x-axis. And we also know how to solve a quadratic equation by factoring. Again, make sure it's set equal to 0. You go through, you find your GCF, and then you factor the problem. So today we're going to take a look at the third method for solving a quadratic equation. So a third method for solving quadratic equations is the square root method. So square root method. This method also allows us to solve quadratic equations that have imaginary solutions. So this is the first method that we've seen where if the solutions are imaginary, we can use it. So if we graph it, if it's imaginary, it's not going to cross the x-axis and we won't be able to use it. If we try to factor it and it can't be factored because it's imaginary, then we can't use the factoring method. But with the square root method, we will be able to find all solutions, the real and the imaginary. We'll be able to find it all. So we'll go through and we're going to do a few examples. And then at the end, we'll take a look at problems and try to figure out when is one way best to use it over another way. So we'll kind of compare all the different methods that we have so far. So the first one, we're going to solve each quadratic equation by the square root method. So number one, we're going to solve x squared equals 16. The opposite of squaring something is you take the square root. So we're going to square root both sides. So x equals plus or minus 4. So very, very simple. The square root of 16 is 4. 4 times 4 is 16. And negative 4 times negative 4 is 16. When you take a square root, don't forget to do a plus or a minus. The next one. 3x squared equals 15. When you're using the square root method, you need to get the square root all by itself first. So there's a 3 in the front, so the opposite of multiplying, we need to divide. So x squared equals 5. The opposite of squaring something is to take the square root. So we'll square root both sides. So x equals plus or minus the square root of 5. So x equals plus or minus the square root of 5. So when you're using the square root method, you need to get the x squared part of the problem all by itself before you start taking the square root. So you cannot take the square root of the problem right here at the beginning. We had to get the x squared part. You got to get that by itself first before you take the square root. Same thing over here. So this one, the square root is already, there's not like a 4 in the front or 7 afterwards. The square is already all by itself. So I can go ahead and take the square root because this time the whole problem is being squared as opposed to over here where only the x was being squared. So this is going to give me x minus 2 equals plus or minus the square root of 6. So x minus 2 equals plus or minus the square root of 6. Now, I am subtracting here, so I can add 2 to both sides. So we're going to add 2. X equals, this 2 cannot be put inside of this square root. So the square root only applies to the 6. You cannot put this 2 inside of here and make 8. That is wrong. So do not do that. This 2 just goes right in front of this plus or minus sign. So the 2 is going to go right there. So my answer is going to be 2 plus or minus the square root of 6.
Anthony Wills, if you're in the building, your ride is waiting out front. Anthony Wills, your ride is waiting out front.
Okay, so I am at school in my room, so you hear all kind of announcements. You might hear the phone ring, etc. So anyway, this 2 does not go inside of this square root. That's like an illegal math move. So notice I just put the 2 in the front. So my 2 answers are 2 plus the square root of 6 and 2 minus the square root of 6. But we can write it all together as 2 plus or minus the square root of 6. Next one. 9x squared plus 25 equals 0. So again, only the x is being squared, so we cannot take the square root first. We need to get rid of the 25, and we need to get rid of the 9. So the opposite of this 25 is to subtract 25 from both sides. So we're doing opposite operation. So 9x squared equals negative 25. The opposite of multiplying by 9 is to divide by 9. So x squared equals negative 25 over 9. Okay, now we need to take the square root of both sides. So the opposite of squaring something is to take the square root. So we're going to square root this side and square root this side. So x equals, now I got a negative that's on the inside here. So we need to pull out I. So I stands for imaginary. So we're going to take out the I part of this problem. So I'm going to go ahead and do the plus or minus. And the I means that I have a negative on the inside. So I'm going to take that part of the problem out. So now I have 25 over 9. So x equals plus or minus I square roots of 25 ninths. Both of these numbers are perfect square numbers, so I can simplify this even more. So my final answer is x equals plus or minus I. And technically, we should put the I behind because we don't say x5, we say 5x. So hopefully you're writing in pencil, so I'm going to put the I in the back there. So our final answer, x equals plus or minus 5/3 I. So x equals plus or minus 5/3 I. So again, a little quick recap. We subtracted 25 from both sides. We divided both sides by 9. Then, if you have a negative underneath your square root, you take out the I, which stands for the imaginary part of the problem. And 25 over 9, the square root of 25 over 9 is 5/3 because these are both perfect square numbers. So we write our answer, x equals plus or minus 5/3 I. So x equals plus or minus 5/3 I. Now, I want to take a look at a few problems. And so the directions here say solve each quadratic using any method. So we have 3 methods so far. We can graph it, we can factor it, or we can now take the square root. All 3 of those are going to give you the same answer. I'm just going to walk you through some ways that you'll know how to use one problem over the other. So say I saw this problem here. So x squared minus 16 equals 0. We absolutely could graph this. So if we were to graph this, we would type in Desmos x squared minus 16 and look for where it crosses the x-axis. I also could factor this problem. So I know that this is a different of squares, so I also could factor the problem. So if we chose to factor the problem, 2 numbers that multiply to give me negative 16, add to give me 0. That would be negative 4 and positive 4. So each factor equal to 0. X minus 4 equals 0. X plus 4 equals 0. So my 2 answers are 4 and negative 4. So this is one way to solve the problem. So the first way I solve the problem is by factoring. Another option that we have today, I could have just taken the square root. So this is x squared minus 16 equals 0. I could add 16 to both sides. So x squared equals 16. Then I can take the square root of both sides. So x equals plus or minus 4. So I also can solve this problem by taking the square root. Now, for this particular problem, personally, if I saw this problem, I see that this is a perfect square number, so I probably would try to take the square root of both sides because I know that it's a perfect square number. It'll work out pretty. Other things you might want to consider, say you try to graph something and it's an imaginary solution. For example, if I move down here to number 3, if you try to graph number 3, it does not cross the x-axis. So that means that graphing isn't going to work. And it also means that factoring does not work because you get decimal answers. So for this particular problem, we're going to have to take the square root. So again, say you try to work this one out and you try to graph it. It is not going to cross the x-axis. So that is not going to help me get my imaginary solutions. Instead, we just need to solve it and take the square root. So I'm going to subtract 12 from both sides. That gives me 5x squared equals negative 12. I cannot take the square root yet. We got to get the x squared by itself first. So I'm going to divide by 5. That gives me x squared equals negative 12 over 5. The opposite of squaring something is to take the square root. So we're going to take the square root of both sides. So x equals plus or minus. I have a negative that's on the inside here. When you have a negative inside the square root, you want to take out the I. So now I have 12 square root of 12 fifths. I could rationalize this and do some more things with this, but I'm going to leave it just like here for the time being. So x equals plus or minus I square roots of 12 fifths. So x equals plus or minus I square roots of 12 fifths. Unlike the other problem that we did similar to this one, if I zoom back out for just a minute, 25 over 9 could be broken down. Okay, 25 over 9 were both perfect square numbers, so I can break that down into 5/3. This one over here, 12 nor 5, is a perfect square number, so I can leave it like it is. And the very last one that I want to look at here, say I saw this problem here. You do have 3 different ways. Graph it, take the square root, or try to factor it. Taking the square root is not going to be helpful for this problem because I have a trinomial. So when you have a trinomial, taking the square root may be rather difficult for you to do. This problem is already set up in factoring form. So we can just think of 2 numbers that multiply to give me negative 20 and add to give me negative 8. So if I set up my parentheses, it's going to multiply to give me negative 20, add to give me negative 8. So those numbers are negative 10 and 2. Negative 10 times 2 gives me negative 20. Negative 10 plus 2 gives me negative 8. You set each factor equal to 0, and you'll get your 2 different solutions. So one of my solutions is 10, and the other solution is negative 2. So for this particular problem, we solved it by factoring. So now we have 3 different ways to solve a quadratic equation. We can graph it, factor, or take the square root. They all give us the same answer, just depending on the problem. Sometimes it's a little easier to do one method over the other method.